Hello everyone. Ever wondered what the supreme engine for making a game is? If you currently have Godot, Unity, or Unreal bouncing around in your brain, get ready to be blown away. Allow me to introduce you to what is, in my opinion, the undeniable champion for game creators, Desmos. Yes, you heard it. Today we will be diving into the wild world of crafting an entire game using nothing but a graphic calculator. To begin, let's start with creating a slider to indicate that the game has started. Next, we shall make a slider which later will allow the player to jump. Then we can start rendering the player. First, we define three attributes of the player: the radius, and the static x and variable y coordinates for its position, which allow it to jump using the curve of a sine equation. This is followed by showing the player itself, using the equation of a circle. Don't forget to change the game and jump sliders to be play once, and increase their speed, game to 20 times and jump to 5 times. Finally, I shall create a folder called Player Logic, and group them by clicking, holding, and dragging them into the folder.
Next, we will work on the logic of the game. Add a folder named Game Logic.
Inside it, create a slider, T, to represent how long the game has been running. We shall now use an important concept in statistics present in Desmos: residuals. A residual, simply put, is the positive difference between an expected result and the one observed. In the example shown, a variable t is created and set to be 3. This is the observed result. The residual of t is then taken with 2, which is the expected result. The output is therefore 1, the difference of 3 and 2. In our case, we would need to increment time, but only while the game is running, meaning we cannot rely solely on the slider's animation. Unlike other programming languages, in Desmos, we cannot have variables referencing each other or itself in a cyclical manner, nor can we have the slider's animation controls reference the current variable or others that depend on this variable for value. On the other hand, residuals can be used to achieve this, since residuals are not treated by Desmos in the same way as a variable. Heading back to Desmos, I shall create a residual of t and create 2 variables which will be used in the slider's animation controls. While the game is running and the variable game is set to 1, the lower limit of the animation of t will be its current residual value, while the upper limit will be this value with 4 added. However, if the game is not running, meaning the variable game is equal to 0, both limits are set to 0. After condensing this folder by clicking on the down arrow to the left of Game Logic, I will create another folder, which will be named Obstacle Logic. Inside, I will create a list called OBS, which contain the positions of each obstacle in the scene that the player will need to dodge. These positions will be based on the values of sine and cosine of the current time multiplied by a variable called speed. This position shall be scaled horizontally by 12 and vertically by 5, as well as being translated up by 5. The path of the obstacles will therefore be elliptical. To render these, I will create a function, circle, which would return the square distance from any point in the graph to an obstacle's position using the Pythagorean theorem. I will then call circle, passing in the list of obstacles, as well as the coordinates of every point in the graph, and color it orange if the square distance is below 1.3. After a quick test, you can now see that when I set game to 1 by dragging the slider, the obstacle moves around the defined elliptical path, and the player achieves a jumping motion. Under the obstacle list, I will create another list containing the radii of each obstacle. This current one will be 1.3.
Now, we shall create a folder called Collision Logic, which will detect if the player is touching an obstacle. We will declare a function to check this, which will take in the index of the obstacle being compared as a parameter. It will then return the squared distance from the player to that obstacle with the use of Pythagoras' theorem. It will subtract the sum of the radii of the 2 circles from this value. If this value is positive, they are not colliding. If it is negative, they are touching. Next, a variable called collision will be a summation of whether an obstacle is colliding with the player. In essence, this loops over each obstacle at index n, and if any obstacle will collide with the player, the accumulative total calculated each frame will be incremented by 1. If this total is greater than 1, we will draw a red rectangle covering the screen, which indicates that the player is touching the obstacle. Note, if zoomed out enough, this will not cover the entire screen. At that point, however, the player and obstacle would be so tiny that the game is practically impossible to play. After a quick test, it's clear that everything functions as expected. Finally, we will create functionality to pause mid-game. I shall create a slider called Pause and have it share similar slider settings to Game and Jump. There will be 2 steps to adding this logic. Firstly, to remove player jumping when it is 1 by restricting the player position to be grounded. Secondly, if the game is paused, the minimum and maximum variables will both be set to E1, the current time. I shall now remove the grid lines, axis numbers, and the vertical y-axis. As well as hide the list of obstacle points that is drawn to the screen. At last, the game is finished. See you soon in the showcase. Please like and share this video, and subscribe. Thank you for watching.